Welcome to the DZEZ Show. I'm Eric Rangel, reminding you to be positive as we explore the ideas of Ted Nelson and dream about building a better metaverse. Welcome to another episode of the DZEZ Show. Here we are looking at a Zoom meeting from the 1960s, which we are going to use as an example for zzstructure. This spreadsheet shows the people who are in the Brady Bunch family, and we're going to start with Alice at the center. So what I want to point out is that dimensions can have no logical reasoning. It's like I could create a dimension called Peter, Carol, Marcia, and Greg. So let's start with Alice. If we wanted to go around and make a snake, we could go from Alice to Peter or any of the other people, but let's just choose Peter as a start, and then we're going to go down and around. So when we go to Peter, let's fill Peter in. And then we want to go down to Bobby, and then across to Mike and Cindy, and fill them, and then up to Jan and Marcia. Okay, and over to Carol and Greg. Okay. So think about this as the game of life. So here is Conway's game of life. And let's draw a glider. Let's make this a 1, 0, 0, 0. So if you use the Brady Bunch cells as the game of life to calculate the next generation, you have to count the number of neighbors that each cell has. So Alice has 6 neighbors. 1, 2, 3, 4, 5. Why? Oh, I didn't recalculate. And when you... so like as I move in this neighbor count cell, you could see which cells are dependent on each other. Okay, so like down here, you only need these 3 cells, and Alice depends on everybody around her. And then it calculates a generation, which is a glider pointing down, and then it gets another neighbor count and gets the next generation. So each generation is a pure function. So when you're calculating the generations, you're comparing these two numbers, the previous and the current neighbor count, and using rules to determine what goes where, which cells are turned on or off. And then counting neighbors here, if you still have a 3x3, okay, here we had to expand the grid a little bit, but still you can see the pattern of dependencies. It's a square showing all your neighbors. Okay, but putting that aside, let's go back here and say we just wanted a ZZ structure to figure out where our neighbors are. So I created a dimension. So theoretically, let's have a dimension called Peter for horizontal connections and a dimension Carol for vertical connections. Just arbitrary choosing people. Marcia for diagonals that go this way, and Greg for diagonals that go this way. So with those 4 dimensions, I could navigate 1 or -1, 1 or -1, and find all of Alice's neighbors. Okay, so let's look at each of these dimensions. The dimension snake starts at Alice, then goes right to Peter, then down to Bobby, and around to Greg. Now, dimension Peter, it will have 3 different ranks: Marcia, Carol, Greg, Jan, Alice, Peter, and Cindy, Mike, and Bobby. So these are just lines. So the important thing is that if you go left of Marcia, that's a nil cell or null cell. If you go right of Greg, that's a null cell in that dimension. So these are 3 disconnected ranks in a horizontal, in dimension Peter. And for the vertical connections, it also has 3 ranks. You got Marcia, Jan, Cindy, Carol, Alice, Mike, and Greg, Peter, Bobby. Okay, so that's also clear from the diagram. Now the Marcia dimension is for diagonal connections on a backslash. Now you have Marcia, Alice, Bobby, but you also have Carol to Peter and Jan to Mike. So those are 3 ranks. Okay, and here's the diagram for the Marcia connections. So there's 1 rank here, 1 rank here, and 1 rank here. And the Greg dimension is for the Greg, Alice, Cindy, the Carol, Jan, and the Peter, Mike ranks. Okay, so this should clear up the concept of ranks between dimensions. Okay, so in the rest of this video, I'm going to show how a relational database structure can store all the information to maintain a ZZ structure. And I'm not going to discuss any implementation details. You could use any technology to implement this. But the one thing I want to point out is the concept of a tumbler as a permanent address of a cell. So wherever, it could be one infinite loop in California. Okay, so tumblers are defined as a sequence of numbers that start with a non-zero, and I'm also adding the condition that they end with a non-zero. The last digit would never be 0, with as many intermediate dotted numbers in between as you want. Okay, so with a table of cells, dimension, and cell connections within dimensions, that will maintain bidirectional links through logic, we can store everything we need to create these dimensions and navigate between them. Okay, so let's look at how we would implement this in GZZ. Okay, so I've just created a GZZ canvas, and I created a place where I created a dimension called Brady snake. So as we defined the snake previously, it goes from Alice to Peter, Bobby. Okay, so over to Peter, down to Bobby, left to Mike, left to Cindy, up to Jan, up to Marcia, right to Carol, Greg, and that's the end of the Brady people. And then if we continue it, we would have cells that I'm just numbering 10 through 25 to make a 5x5 grid. Okay, now every one of these cells exists in every dimension. Any cell in a ZZ structure exists in every dimension. So, like, Alice is in the royal families of Europe, obviously. Okay, so now let's go to our edit window. So that's 9 capital G. Okay, and move it down here so we could change Alice's name if we wanted to. But for now, what we want to do is follow the spreadsheet and create the ZZ structure that is illustrated in this spreadsheet. Numbers. Okay, so we've created cells, but let's look at what we would do. So starting from scratch, we create a cell for Alice, and arbitrarily picking a tumbler of 2.0. It could be anything. But we have to give the cell an ID, so Alice is number 1, and version 1, if we change her name later, we would have a new version of the cell. And that's a permanent address, which points to anything, a file, a picture. Okay, and we are going to create a new dimension. Dimension ID 1 is cell ID 2, which is a dimension called snake. So I chose to use the tumbler 1.0.1 for the dimensions. So anything under 1.0 is a dimension. So dimension Peter is 2, 3, 4. Okay, so say we just needed to create those 2. So I'm going to highlight the rows that I create as we go. So we want to start with these two and this first dimension. Okay, so the cell ID of the dimension will point to the cell that defines the dimension. So if we need to rename this to Brady snake, we could change the contents at this address and it would have a new name. But we want to keep every version, so that would be a version 2 of this cell ID 2. And that's the primary key. Okay, and the primary key of the dimension, we could have versions of the dimension table. So like say we renamed snake, we would have version 2 of dimension 1, which would also have cell ID 2, but it could point to a different cell ID theoretically. Okay, the data that we want to use going forward is in here, the connections between cells within dimension. So the first thing we want to do is on dsnake, we want an Alice going positive in the positive direction to Peter and negative, and then the Peter cell going negative to Alice. So we also need Peter. So let's add the creation of Alice and Peter. So there are no connections until you have at least 2 cells. So let's fill Peter. Okay, so say we've created these 3 cells, Alice and Peter, and it's in the snake dimension. So all we are showing here is this link between Alice and Peter. Okay, so all we're creating here is this little line connecting them in the Brady snake dimension, which I call just dsnake in the spreadsheet. Okay, so how would we do that in a table? Okay, so we have to connect Alice positive to Peter. And so the positive and negative are just directions. So this is a directed graph. Okay, so dimension ID 1 points to this cell ID 2, which is the name of dimension snake. So we are connecting in dimension snake cell ID number 1, which is Alice, and version 1. Okay, so you'll see versioning later as we supersede data in these cells later. But we're starting with version 1. Now the negative cell ID, currently Alice has no negative neighbor, even though I needed to attach it to something. Just ignore this cell for now. So Alice has a nil as her left neighbor, and Peter has a nil in his right neighbor. So that's where you see nil in the negative cell and nil in the positive cell for Peter. So the positive cell ID is 3. Okay, so 3, you could go back and look up, that's Peter. So this first row, it's connecting Alice and then going positive to Peter in dimension snake. Okay, so we understand that. Let's highlight it. Okay, now also in dimension snake, we need Peter to have a negative connection to Alice. So in dimension 1, cell ID 3, okay, dimension 1 is still dsnake, cell ID 3 is Peter, and we have a version 1 going negative to 1, which is Alice. So that's how we capture that relationship. So yeah, I'm just going to keep, so whatever is filled in, we've visited already. Okay, so we've handled these 2 rows. So these 2 rows will need to be inserted as a logical unit of work, that either both rows get inserted successfully or none of them, and you roll back. Your application handles the exception. Okay, so now what's the next thing we want to create? We go to dpeter. Okay, so now we are going to add a dimension called dpeter. So let's do that in zigzag by hitting escape and scrolling down. This is Ted Nelson's zigzag prototype, but this is GZZ. So we created dimension Brady snake. We're going to create a new dimension going connecting down to from Brady snake, and we're going to call it dpeter. Okay. So again, you could call things whatever you want. There's no rule. You're making the rules as you go. Okay, so now I'm going to here set my x-axis to D Brady Snake and my y-axis to D Peter. Okay, so what is D Peter? Well, looking back here, we want to create the dimension in D Peter that Alice is to the left of Peter and Peter is to the right of Alice, where Alice is Peter going negward and Peter is Alice going posward. Okay, so to create a new dimension, we need to insert a row in the dimension table, but we need this, it references cell ID 4, so we need to create the cell for the new dimension. Okay, and we need to, let's see what I could do, yeah. And then we need to create the dimension entry. So these IDs are auto-incrementing fields. So this is the first version of dimension number 2, which is pointed to cell 4, which is the Peter dimension. Now, let's talk about the tumbler. So as a convention, I decided that I want my tumblers to maintain an alphabetical sorted tree. So as I'm inserting Peter, I want it to be where you could navigate in order of the tumblers. So like 2.0, it goes from A to P, 2.1, but then Bobby, I want to insert between Alice and Peter. So by going 2.0, 2.0.1, and 2.1, I could traverse that tree in order of the tumblers and get an alphabetical index. But that's just what I chose. It's like a clustered index, okay, in a database sense, but just consider the tumbler a permanent address of a cell for now. It's up to you how you organize it physically. So this could represent directories on a disk. Like maybe you have a hyperdrive and a directory called 2, and under it you have a 0 directory and a 1 directory, and then under the 0 directory you create a file 2.0.1 or a directory 2.0.1. You could explore those ideas in my GitHub. Okay, so let's see what we want to do with D Peter. So now we want to, on D Peter, we want to go from Alice posward to Peter. So in dimension Peter, cell 1 is Alice, version 1. So see, every cell exists in every dimension, but now we're creating a connection. So we store all the connections between cells. So we want to go positive to 3. Okay, so let's highlight this. Okay, and let's make that connection. Okay, so in D Peter, we want to go connect, we want Alice going down to Peter in this dimension. So in the left panel, what I want to do is navigate to my Brady snake. So let's make the Shift X to dimension Brady snake. And let's go to Peter. Okay. And let's connect with the slash. So slash comma connects D Peter. Let's see. Okay. So what we want to do, first I'm making sure I'm in row view, and Brady snake is this X dimension and Peter is the Y dimension. So I've highlighted Alice with the blue cursor and Peter with the green cursor in the left window, and I'm going to make a connection going in the vertical dimension of D Peter. So I want to connect Alice going posward to Peter in the Peter dimension. So I type slash comma, and that creates this link. So on D Peter, Alice is connected to Peter, and Peter's connected to null, and Alice is connected to null negward. And then you can see the Brady snake dimension going here. Alice goes to Peter, goes to Bobby. So GZZ draws a spline, which is a quadratic or cubic equation that is used to calculate the pixels for a curve. Okay, so that's the first connection. And then we need Peter going negative to Alice. Well, that's implied in this ZZ structure, that Peter going negative to Alice. So like if I do comma, that's going down in the y-axis, which is going posward in D Peter. And if I type an I go up in the y-axis, which is going negward in D Peter, and then I can't go up and I can't go further down. But in a database, we need to explicitly create the two rows together. So here we're saying dimension 2 has, so the cell ID 3, Peter, version 1, has a negative partner at 1, Alice. Okay, so let's highlight that. Okay, we're done with that link. Okay, so now we are gonna create Bobby. Okay, so we need to add cell ID 5 for Bobby, which we've already done in zigzag GZZ. Okay, so Bobby is cell 5. I explained the tumbler already. And we're not creating a new dimension yet, but we want to add Bobby to the snake. So Peter needs a positive connection to Bobby. So we're in dimension 1, which is the snake. Cell 3 is Peter. And version 2, because we've already used version 1 here, where we have a connection between Peter and Alice. So what we need to do is copy whatever we had first. We have a 1 in the negative cell, and now we're adding a 5 in the positive cell to replace this nil. So that is an insert of a copy of a row, okay? So that we maintain the relationship. So now watch what we can do. We can go from Peter to Bobby, and we could go back from Peter to Alice. So in dimension 1, cell 1 is still active, and that is the cell ID 1 is Alice, and then we could go forward from Alice to 3. So you look up 1, 3, and you get to cell ID 3 is Peter, and then if you want to go forward again, you can go to the pos cell ID 5, and 1, 5. Okay, so where is 1, 5? It's going to be here, okay, which is Bobby. So, these have to be created in pairs, otherwise you don't have a valid structure. Okay, 1, 5 is Bobby, and we haven't created dimension Bobby yet, so let's hide. So for Bobby, the negative cell is 3 for Peter, and it has no positive neighbor, so we'll highlight that. Okay. The blue just means that later on this is going to get replaced by a new version, because in the snake, Bobby has another partner going around, which would be Mike over here. So we haven't gotten there yet, but we've done this. So what have we done? All we've done is we've connected our snakes. So if you imagine that we only had 2 people in the snake, we added Bobby to the snake, and we created this link. Okay. Next, by adding Bobby, we actually have 3 cells, and what I want to do as I create these cells, I want to capture all relationships. So we saw that Alice and Peter have a relationship, in the Peter dimension, and now Peter and Bobby have a relationship in the Carol dimension. So what we need to do is create a dimension for Carol and add a relationship Peter posward to Bobby and Bobby negward to Peter. So that's the next step. We have to create a new dimension for Carol. Okay. And now we have to find a tumbler to store Carol. Well, for dimensions, by using this convention, it's just going to increase the third digit of the tumbler for each new dimension. So 4, 5, etc. Okay, so we create dimension 3 pointing to cell 6, which is the name D. Carol. Okay. All right, we have 3 dimensions. Now what we need to do is connect the cells. 3 is the Carol dimension, and we're connecting 3 and 5, which is Peter and Bobby. You can double check it here. 3 is Peter, 5 is Bobby. Okay, so Peter going positive to Bobby and Bobby going negative to Peter. Okay, so with this table so far, you can navigate Alice, Peter, Bobby in 3 different dimensions. And that's the idea of zzstructure. It's whatever dimensions you want, and you have to think about the design of your application and what kind of structure would best support it. And these neg cell IDs and pos cell IDs are not part of the key because there is a rule in zzstructure that within any dimension, any cell can only have one negative and one positive partner or neighbor. Okay, negative neighbor and a positive neighbor. So in any dimension, any cell can only have one negative neighbor and one positive neighbor. If you needed to do a many-to-many relationship, you would have to create a dimension called declone and connect the cells on the clone dimension and use that clone for navigating to clones of an existing cell. But we're not going to look at that right now. Okay, so what we want to represent now is in dimension Carol, Peter, and Bobby. So we need to create dimension Carol. So let's go back and go down to the dimension list. After Peter, we're going to do a new going down, and we're going to edit this cell to be D. Carol. Okay, and then escape and go back up. Okay, so X is the Brady snake, and we can go Y is D. Peter, but we can also change Y now to D. Carol, and we're going to connect Peter down to Bobby in D. Carol. So on the left pane, I want to go to dimension Brady snake and go up here. D1, I need to go to the right and then change the X in the left window to Brady snake. Okay, so now I want, on the left pane, I want to move the green cursor to Bobby, and I want to connect them vertically, which would put them on D. Carol. So slash comma, we now have Peter and Bobby connected vertically on D. Carol. And what that represents is this link here. Okay. Next, we need to create a dimension Marcia because we now have an Alice to Bobby relationship. Oh boy, Alice is getting around here. Let's go create D. Marcia. Okay. So we fill her in with orange, tan. Okay, so we need to create a dimension called Marcia, and that is 7, which becomes the cell ID pointing to dimension 4. We create the dimension here, and let's add that dimension to our system. Okay, dimension list. And Marcia. Marcia. Okay, and let's go back. Okay, so X is the Brady snake, and Y is, okay, so Peter, Carol, and Marcia. Okay, now let's look at the left pane and go up and over and change X back to Brady snake. Okay, so who are we connecting? We are connecting Alice to Bobby. So we move to the right on the Alice. So the blue is Alice and the green is Bobby. Okay, so here's the connection in dimension Marcia. Alice is number 1 and Bobby's number 5. So 1 goes to 5 in positive and 5 goes to 1 in negative. Okay, so these two rows we're going to implement. Okay. So here to do that we do a Alice / comma to connect in dimension Marcia. We're connecting Alice down to Bobby. And that's how it's done. So the Brady snake dimension goes Alice, Peter, Bobby, Mike, Cindy, but the Marcia dimension goes Alice, Bobby. Okay, and what is that showing here? Alice to Bobby in the Marcia dimension. Your mind getting twisted a little bit here? Okay, now we're going to add Mike. And we have to add him to the snake, and then we have to do a few more things for Mike. Okay, so Mike, his tumbler, we need to insert an M into this alphabetical list. So he's after Bobby, but before Peter. So 202 becomes his tumbler. Okay. So imagine a directory structure. You create two as subdirectories, and then you put a picture of Mike in there as an example. Okay, now we have to connect Mike into the system, because just creating the cell, it's not connected to anything. So you need some place to put new cells, and in GZZ there is a cell creation dimension for that, for things that may not be connected to anything else. So adding Mike, who is number 8, we need to, let's see, snake, we need to find, he's going to be after Bobby in the snake, because looking here, he's Bobby going, we're going left, but we're going posward in snake. Okay, get that? Snake goes from here to here to here to here. Okay. So, Bobby, pos to Mike. So 5 is Bobby and pos to Mike. And 5 version 2. So where was 151? We had a 3. We have to obsolete this row and create a version 2 of this 1.5, and we will now do this. So like in a relational database, you could have a view that always shows the latest version of these 2 cell combinations, but implementation details are not going to be discussed here. You could have other columns for back pointers or other stuff, but that's for your programming experts for performance tuning. So we don't want to optimize performance too soon. We don't want to prematurely optimize. Okay, so dsnake, Bobby, pos, Mike. So Bobby, okay, so our snake dimension already has that. That's that little line connecting those 2 cells. And then the Mike negative to Bobby. So dimension 1 is the snake, 8 is Mike, and it's the first version of that row. 5 is Bobby, and no positive cell yet. Okay, so that's done. Okay, now by adding Mike, we have, what do we do when we add Mike? We have a square. We have a Carol dimension here, we have a Peter dimension here, and we have a new dimension called Greg for this relationship. So there are 3 relationships or 6 rows that we have to add. So Mike had relationships with the whole family. Uh-oh. Okay. So I'm going to add dimension Greg first. Okay. 1.0.5. Okay, so we add a new dimension pointing cell 9. So this is the first. So these are our 5 dimensions that we need for our navigation. Okay. And that'll allow us to find all neighbors of any cell in the system. Okay, so now Greg. And if you think about the game of life, as we go around and expand this further and further, if we just keep following these rules and creating all the neighbor connections, we will have all the mechanism we need to navigate in any direction from any cell and to traverse, starting at the beginning of the snake, to evaluate the game board for the next generation. Okay. So let's just follow this through. D. Peter, Mike pause to Bobby. Okay, in D. Peter. So what we want to do is Mike, the blue cursor on Mike and the green cursor's on Bobby, but we want to create the Greg dimension first. So go down here. So if you could think of all your dimensions up front, it might be easier to create them all first, but I'm just showing you as an example, creating them as we go. So you could do either way, it's your workflow. All right, new cell comma below it, and D Mike, D Greg. Okay, the Greg dimension. Okay, let's go back, and back to where we were. And X is Brady snake, and Y. Let's go to the new dimension. So Peter, Carol, Marcia, Greg. Okay, and who are we connecting? So it's on the x-axis. Let's go up to here, and X, Brady snake, undo. What we need to do is go back to dimension 1. Go around here. Okay. Dimension 1, we have to go to the right, and then change X to Brady snake. Now we got him. Okay. So we are going to connect Bobby and Mike. How are they related? Okay, so the first one we're doing is in the Peter dimension. Okay, so let's scroll this around to the Peter dimension. We'll eventually get to the Greg dimension. So let's do the y-axis all the way around. Okay, Peter dimension. And Mike is, okay, so Mike is going in the posword, wait a minute. Oh, in the Peter dimension, yes. We are going from Mike posward to Bobby, because the Peter dimension is horizontal rows. So this is negward and this is posward. So Mike going posward to Bobby and Bobby going negward to Mike. So in the Peter dimension, Mike going posward to Bobby is a slash comma. So that establishes that relationship here. Okay, and then in the table, it's 8 is Mike, right? Yeah, 8 is Mike, and 5 is Bobby. So dimension 2 is Peter, and you have 8 going to 5 and 5 going to 8. So we're done with these 2 rows. Okay, now Mike is also connected to Carol. How nice. Uh, okay, so what's this? Alice, Paz, Mike, and Carol. What are the three of those people doing? All right, so we're not creating Cindy yet, where you don't need any new dimensions. We're creating a relationship in the Carol dimension. So looking at the Brady bunch again, the Carol dimension is vertical. And so far, we only have these 4 cells in our system, so we need an Alice going posward to Mike and a Mike going negward to Alice. So Alice pos to Mike and Mike neg Alice. So Alice is 1, Mike is 8. So dimension 3 is Carol. You could verify it here. So 3 goes to 6, goes to Carol. Okay, so let's connect these. So we understand what they are now. We'll just highlight what we're doing. Yep. Alice goes to Mike and Mike goes to Alice. In Alice's restaurant, or Tom Lehrer song. Okay, so Alice in dimension Carol. So let's change the y-axis on the right to dimension Carol. And we want Alice posward. So the blue cursor goes to Alice. And the green cursor has to go to Mike. And now we slash down, and now we have on dimension Carol, Alice to Mike. Okay, and we can chug through the rest of these. Now, chug is a technical term. It's not about beer. It's about navigating in dimensions. Okay, Greg. In dimension Greg, Mike pos to Peter and Peter neg to Mike. So dimension Greg is this diagonal dimension. So Mike pos to Peter and neg. So where's neg and pos? So see, yeah, positive is upward, but in this dimension it's negward. So really your choice of positive and negative is arbitrary as long as you are consistent. So here I'm saying Mike goes positive to Peter and Peter goes neg to Mike. So you want to draw a diagram of your directions and your positives and negatives for yourself. The system will do whatever you want, but your brain has to think about what you're doing. Okay, so we chose Mike pos to Peter and Peter neg to Mike. So 5 is dimension Greg, right? Yes, 5, 9, D Greg. Okay, 8 is Mike and 3 is Peter. Just verify that. 8 and 3, good. Okay, so what we want to do now is implement this relationship in D Greg, Mike going positive to Peter and Peter going negative to Mike. So Mike is 8, Peter is 3, dimension 5 is dimension Greg, and here's your 8 to 3 and 3 to 8. Okay, so we'll color those in, and we'll implement it. So Mike in Greg, we're going Mike down to Peter. Okay, so slash comma, we have that posword. Okay, so, but looking at it up here, Mike and Peter is posword, yes, in one sense of the word. Okay, what's next? We have to add Cindy. Okay, so looking at what we have, if we just go around the circle again, all of Mike's connections going back to Brady Snake. Okay, so Mike goes in the Peter dimension, which is horizontal, Mike goes to Bobby. In the Carol dimension, which is vertical, Alice goes down to Mike. And in the Marcia dimension, he doesn't have one, but in the Greg dimension, Mike goes northeast to Peter. Okay? That's the power of zzstructure when you can navigate in counterintuitive ways. Okay, so now let's just add Cindy, Jan, Marcia. All right, we're going to create Cindy. Now C comes after CA, so okay, we didn't create a Cindy dimension. We're creating a Carol, where we haven't put Carol in the system yet. So for the people we have Alice Bobby comes after Bobby. So 2.0.1.1 will be Cindy's Tumblr. Okay, because I'm keeping an alphabetical clustered index. Okay, no new dimensions. Now let's connect Cindy to the snake. Okay, Cindy is cell 10. Okay. Yeah, this cell will get overwritten later, but we're creating it from version 1 to start. So Mike in the snake dimension goes positive to Cindy, so that is this relationship here between Mike and Cindy. Okay, so let's take this. Okay, so in dimension 1 snake, 8 is Mike going pos to 10, and 10 is Cindy going neg to Mike. Okay. So the viewing of this data is up to you. What we're doing is providing the data structure so you could navigate in any way you choose, and it's up to the GUI designer to figure out how to display this data in a way that makes sense to the user in the application you're building. So we want to connect this we've already connected that. Now, by adding Cindy, the Peter dimension, the horizontal, we have a Cindy going positive to Mike. So 2 is dimension Peter, 10 is Cindy, first version, 8 is Mike. Now 2.8 already existed up here, so we copy 2.8 version 2. Okay, so we forgot to copy the 5 from here. Okay, so it's easy to make errors here when you're doing things manually like I am. Okay, so what is this saying? A new version of dimension 2 cell 8 has 8 is who? Mike. Mike has a left neighbor of Cindy and a right neighbor of 5, Bobby. Okay, so let's do this in GZZ. Go to dpeter. Okay, y-axis. Okay, I'm going to go around. Okay, in your system, have an easy way of going backwards in dimensions. All right, dpeter, we want to connect Cindy pos to Mike. So Cindy is the blue cursor, and Mike is the green cursor. Slash comma. Look at that. We have Cindy to Mike to Bobby. That connection creates this rank, which is this rank down here. Okay? You could change your view to column and look at things differently, but I'm not going to confuse you. Yeah. So views are up to the designer as well. If you create the right views, your structure will have natural navigation. Okay. Same thing in a database. Creating the right views will make your developers happy, not to think about complex interrelationships and calculations or whatever. Okay. Yeah, think about functional programming in this type of structure as a research project. Okay, dimension Greg. Greg is a diagonal dimension. Cindy diagonally goes to Alice. So looking up here, that's this Cindy going to Alice and eventually to Greg, who doesn't exist yet. Okay, so you can have views of time. See, this is a time-ordered series here. So what you should have is a surrogate key that's an auto-increment field on this table as well. All right, 5 to 10. Yeah, dimension 5 is Greg. Did we do that yet? No. Okay, so let's go to dimension 10 is Cindy, 1 is Alice. Okay, and then Alice going negative to Cindy. Okay, so let's do that. 5, Greg, Cindy to Alice. So left cursor and on Greg. Okay, so Cindy going in the Greg, posward on Greg gets to Alice, and Alice going negward on Greg gets to Cindy. Okay, who are we adding now? Jan. Okay, we're adding Jan into the system. And J comes after C, but before M. So she fits right in there, 2.0.1.2. Okay. Your clustered index can be anything, but it must represent how you want to physically store the data. So this could be a B tree or any other structure you want. Okay, Jan, not January. When you type that in, it autocorrects to January. So cell 11 is Jan. Okay, so on our snake, we need from 10, Cindy, positive to 11, Jan, and Cindy's left neighbor in snake is 8, which is Mike. See? So 110 version 2, we're copying the 8 down and we're adding 11. And then dimension 1 for cell 11, first version, we're going left from Jan to Cindy. That's what these numbers represent. This is a good mental exercise to keep your brain working. All right, from dsnake, we've already have that. So we created our snake, or this little line between the two cells. Now Peter, we added Jan. So by adding Jan, we have a horizontal relationship. We have a Marcia relationship. We have a vertical relationship. We don't have a Greg relationship yet. When we get to Carol, we'll create that Greg relationship. Okay, so Jan. In dimension Peter, we want Jan to Alice. Okay, so 2 is dimension Peter, 11 is Jan, 1 is Alice. Okay, so here we have a version 2 of 2, 1, which is up here, way back. We have a 3, so we copy the 3 down and we add the 11. Okay, so let's do that. Peter, Jan, pos Alice, and Alice neg Jan. So all this stuff here I'm showing you is a test case that you can build into any ZZ structure that you are building. Okay. And then if you keep going with the game of life, you can create some ZZ cell programming logic and test that. Okay, so Peter, Jan, Alice. Not Peter, Paul, and Mary. Peter, Jan, and Alice. A new band. Sunshine day, everybody's smiling. Okay, dimension Peter. Y. I gotta go all the way around again to Peter, which U for undo will get you back there. In dimension Peter, Jan goes pos to Alice. So Jan is on Brady snake, and Alice is already connected, slash comma. Look at this structure here. Bobby, Brady, Alice, Peter, Jan, Alice, Peter. So what is Jan, Alice, Peter? That's this horizontal row in the Peter dimension. I could have called it the Jan dimension, but I wanted to balance the women and the men, so I chose this way. I could have gone this way. All right. So we have a nice relationship there. That's a rank. And there won't be any cells to the left of Jan or to the right of Peter until we go all the way around and create the 25 5 by 5 cell grid. All right. So we're just going to finish the test data that we have here. And I didn't go all the way. Okay, so dimension Carol, Jan positive to Cindy. Okay, so we didn't create Marcia. We have dimension Carol, which is dimension 3, which you can verify by going back 3, 6, 6 Carol. Okay, so 11 is Jan and to Cindy. So we're going vertically now. So 11 to 10 and 10 to 11. Okay. So they're both version 1 because no other vertical neighbors exist on this leftmost vertical rank. Okay. So that's what we're going to create. Let's go to the Carol dimension. X, Y. Brady, Peter, Carol. We want Jan to Cindy. Jan is blue, Cindy is green, and slash comma. Okay, so in Carol dimension, Jan and Cindy are a rank of 2 cells. And Cindy is neg to Jan. Dimension Marcia, Jan pos to Mike. Okay, do we have Marcia? Of course we do. Jan is connected to Mike in the Marcia dimension like that. The Marcia dimension is this backslash. Okay, so we create that rank, Jan to Mike. Numerically, dimension 4 is Marcia. And Jan to Mike is 8, and Mike to Jan is 11. So now that we understand that, highlight it. Okay, Marcia. And which dimension? We're going into dimension Marcia. So Y, Marcia, Jan and Marcia. Oh boy, sibling rivalry. Marcia, Jan pos to Mike. So Jan is here and Mike is here. And we have the Marcia dimension, Jan to Mike. Marcia, all right, yeah, so Mike neg to Jan, we got that. Next, we're going to add Marcia to the system. So Marcia, Marcia, Marcia. So 2.0.2 is Mike. Marcia's before Mike, so we just add a 1.3 and we keep that in that index in order. So databases have a balance between index maintenance and other stuff. Okay. Yeah. Because if you have too many indexes, as you're inserting, you got to maintain every index for every insert. But I've never seen that to be a problem in systems I've worked on. Okay, snake, we've already got it on the snake. So Marcia the snake. All right, 11. So here's a version 2 of 111, which was up here. We copy down the 10. We add 12. So that's Cindy to Marcia. No, that's Jan to Marcia. Yeah, so, okay, so Jan's left negward neighbor is Cindy, and Jan's posward neighbor is Marcia. And Marcia's leftward negward neighbor is 11, or Jan. Got that? Okay, so the snake was already created from Jan to Marcia. Only 2 more on the snake there. Okay, so now Carol. By adding Marcia, we have a Carol relationship and a Marcia relationship. So Marcia is both a cell and a dimension. And that's seen here. You have a horizontal, which is on the Peter dimension, and a vertical on the Carol dimension. And did I get that right? Marcia has a Alice, so I forgot to add the D Peter. Okay, so now we have Marcia. Well, you know what? We don't have Carol yet in the system. That's why. Yeah, so currently we have Marcia in the corner. We have a down and we have a Marcia dimension. So down and diagonal. So there are two that we add at this time. So as an exercise to the reader, you complete the rest of this table. Exercise to the YouTuber. Okay. Dimension 3 was cell 6, which is Carol, which we got right over here. Carol. Marcia is 12 and Jan is 11, and Jan neg to Marcia. So Jan's 11 and neg to Marcia is 12. Pos to Cindy, that was copied, so version 2 of a 311. So you got to find the 311 here, copy the 10 down, and logically delete. So that's a good idea to use logical deletion for these. So then you could just select the current row, the most recent. And if you need to go back and look at versions, you could save it in an audit trail, whatever you want to do. Okay, so whoops. All right, Carol, dimension Marcia to Jan. So let's go to Y is Carol. Peter, Carol, Marcia, and Jan. Okay, Marcia goes down to Jan, and is that pos word? Yeah. Well, based on what I said here, yeah, you have to look at a diagram as you're building this. Okay, so slash comma, Marcia, Jan, Cindy. And that is the vertical rank of the girls. Okay, positive is down, opposite of Cartesian coordinates. Counterintuitive. Okay. Understand? So we got, Marcia going down to Jan, Jan going backward, negward to Marcia. And Marcia pos to Alice in the Marcia dimension. So let's look at that Marcia dimension. Change the y-axis to Marcia. And we got to get the Alice cell in green. Alice looks good in green. Today is St. Paddy's Day. Happy St. Paddy's Day, Ireland. And what do we got? Marcia, Alice, Bobby. Look how that all connected up. We have here Marcia, Alice, Bobby. In the when we have another another Marcia dimension. So Alice can find her diagonal neighbor and the other diagonal neighbor. She can use dimension Peter to find Jan and Peter. She can see Mike. For now, she doesn't see Carol yet because we didn't create her. And then she'll be able to see Greg. And that is the game of life. The parents and Alice are deceased, but the kids are all in their 60s now. Okay, let's finish this for now. Color fill. Marcia in dimension 4, which is Marcia. 12 positive to Alice, and Alice neg to Marcia, which we did here. And that concludes this episode of the DZ Easy Show. Happy coding. The files for this episode can be found in github.com/erangel/articles, and then you navigate to the DZ's test cases directory. So this bradylife.zip, the contents, if you unzip it, it'll give you the GZZ files if you want to open it into your own GZZ. The numbers is an Apple spreadsheet for Mac OS, and the PDF is a printout of that spreadsheet. So you could print this out and look at it if you don't have a Mac.